Good evening, my name is Caio, and the title of my project is Do Fiddler Crabs Use Vision to Guide Themselves Underwater? The Effects of the Variation of the Tides in Antipredatory Responses of Leptuca thayeri. Predation is a very important ecological process will influence factors as density, reproduction, morphology, and behavior, and that preys identify and react to possible predations stimulated by sensory cues can be visual, mechanical, or chemical, and this identification can stimulate some responses such as escape, postural freezing, search for shelter, and change in the animal's activities. The model chosen as prey is the fiddler crab Leptuca thayeri. It is an intertidal organism with evidence of activity in both tides, and it also uses visual and chemical stimuli to recognize predators. The predator model chosen was little blue heron, and we chose this bird because it feeds on these crabs and also because it forages in both tides. Okay, considering that feeder crabs are components of both the diet of aquatic and terrestrial predators, our objective is to evaluate whether the tidal variation will affect the behavioral response of Leptuca thayeri to a visual stimulus from the little blue heron predator. For this, we initially collected only adult males of Leptuca thayeri in the Portinho mangrove, and after these individuals were identified and measured in millimeters carapace width. To carry out the experiments, we had 4 treatments at low tide and the same 4 at high tide. The stimuli used were the Little Blue Heron model, an empty 20-liter gallon of water, an Avicennia shaweriana branch, and a control without any object. We performed 12 replicates in each treatment, totaling 96 replicates, and evaluated the following response variables: shifts between quadrants in aquariums, latency to return to normal activities after the arrival of the visual stimulus, latency to return to normal activities after the pendulum movement of the visual stimulus, postural freezing time, and visual stimulus escape. We observed each aquarium for 10 minutes, 5 minutes pre-stimulus and 5 minutes post-stimulus, separated by the visual stimuli. In the lab, the crabs were placed in aquariums under 2 conditions: either they were submerged or they were out of the water. So, in this scenario, we took the visual stimuli to meet the crabs. We made a pendulum movement simulating the natural movement that the little blue heron makes to capture its prey, and then we left with the stimulus. To analyze the data, we used the delta on variables that had post and pre-stimulus responses. We also evaluated the normality of the data using the Shapiro-Wilks test and the homoscedasticity of the data using the Bartlett test. The response variables were analyzed by a generalized linear model with many distributions. We also used the Tukey test to investigate significant factors. Looking at the results, we can see that significant difference in the number of freezings variable, and in this difference will occur between the treatments, specifically between the control and gallon treatments, with the control being greater than the gallon. We also had significant differences in the freezing time variable. In this, the significant difference occurred in the interaction of treatments with the tides, and in the table below you can see the results. Fiddler crabs can use vision to recognize predators, and they will recognize the threat as dangerous or not by its position on the visual horizon of these crabs. That is, the speed, shape, or absolute size of these objects will not be used to define predation danger. Also, in relation to the perception of the predator in the water, the turbidity, propagation, and intensity of light can affect the vision of the fiddler crabs when they are submerged. The aquatic environment has greater viscosity, density, and resistance than the terrestrial environment, so the energy expenditure will be greater for an escape in these environments. Therefore, this may explain why the response variables that presented differences were related to freezing, since freezing is an anti-predatory strategy but with reduced energy expenditure. So, in our research, it is possible to see that fiddler crabs do exhibit anti-predatory behavior using vision when they are underwater. My bibliographic references. Continuing. Finally, I would like to thank everyone who helped me in this project, my friends and family, FAPESP for funding this project, my research group Labecom, and Professora Tânia, Alexandre, and Caio. Very thanks.